Okay, friends, so welcome to CivilPrep. This is a RePrep program, okay, where we'll be looking at the life evaluation and mentorship. Okay, so here in this question, we will see that we have certain aspects which will be taken up from the geographical optional perspective. So the first question we have for the discussion, that is the only similarity between oceanic crust and the continental crust is that both are crust. So elaborate on this part. Okay, just before starting, I'll just make a check here. Okay, so let's come back here again. So the only similarity between the oceanic and continental crust is that both are the crust. Elaborate. So this is a very good question and it is asked for 10 marks. So we can introduce here with the crust that both the are named as crust as they form the topmost layer of the earth. Okay. However, both of them have no chemical and physical similarities. Okay. So this we can see that this is a bit extreme statement. Okay. We can say here that they have certain chemical and physical dissimilarities. Why? Because there are certain components in the oceanic crust as well as in the continental crust, which are quite similar also. So we cannot just, because this statement, it is specifying that this is the chemical composition and the physical composition of oceanic crust. And this is chemical composition and physical composition from uh, the continental and oceanic crust, which are almost different. Okay. So this Venn diagram, it can explain that how it is presented here. Okay. Second thing, what I would like to ask you in the introduction, that you can provide here the plates. Okay. The plate term. This was given by Tuzo Wilson. Okay. And it is studied under the plate tectonics model, where the various other geographers like Morgan, Mackenzie, and Parker were also involved here. Okay. So what we will see that this will give us a better insight for the crust, or we can say the plate, which we are trying to explain here in this question, and how they are having a perspective through this particular terms. Okay. Now let's move for the difference between the oceanic and continental crust, which is the part of the question. So basis is there oceanic crust and the continental crust. So here we have oceanic crust 60 to 80 kilometer thickest at mountains. Oceanic crust and continental crust 1 to 3 kilometer. I think you have written here opposite. This is continental crust. And this is oceanic crust. Okay, so continental crust, yes, it is 60 to 80 kilometers thick, and oceanic crust, it is 1 to almost up to 5 kilometers thick it is. Okay, density will see that it is having 2.5 to 2.9. In average, it is having almost around 2.75 grams per centimeter cube. So this thing is very much important to provide here. And the oceanic crust, it is having a density of 3 grams per centimeter cube. Apart from this, if we look at the oceanic crust in the part of the asthenosphere, it has 3.25 grams per centimeter cube. So this is the density of the asthenosphere. This is of oceanic crust and this is of continental crust. Then composition will say that made up of non-ferromanganese and felsic rocks. Okay, for example, granite, diorite, andesite. Okay, excellent, very good. Made up of mafic rocks. Okay, like basalt underlain by the gabbaro. Okay, excellent point. Okay, so here the buoyancy will be seen that it is high in the oceanic crust, sorry, in the continental crust, and it is low in the oceanic crust. So continental crust do not subduct into the mantle. Okay. Yes, you are going right. So it does not subduct into the mantle because of low buoyancy. Okay. So older and oceanic crust subducts into the mantle because of high buoyancy. If we want to talk about the buoyant feature here, so how we can provide the buoyancy part here? So you can include the part of uh, Bowman's series reaction. Okay, so here we can specify that how we have magma, which is more, we can say, ultramafic first. So from ultramafic, it is becoming mafic. From mafic to it is becoming andesitic. And from andesitic to it is becoming felsic. Okay, so here we'll be seeing that the silica composition, it is increasing. For example, if it is here 20, so here it will be 30, here it will be 40, and here it will be 50. So therefore, we'll be seeing that how there is a series of reactions taking place and it is resulting into the buoyancy also. So here, the magma, it is becoming lighter as the silica, it is increasing. Okay, so because of the increase in silica, the buoyancy, it is increasing here. Okay, so we can explain it here that felsic magma, okay, it is more towards the part of the continental part, and the mafic magma, it is more towards the part of the oceanic part, as we have already provided here, the mafic magma and the felsic magma. Okay, felsic rocks. Okay, so we can provide it is this through this diagram, or that is the Bowman's reaction series, that is a part of buoyancy. Okay, age we can see it is older in age. Okay, so older we will see that the continental crust, they have been formed almost around we can say 3.8 billion years ago in the form of continental nuclei. Okay, which is explained very well by the non-catastrophic model. 12 will be saying that they are younger in age. Okay, they are continuously forming by the lava. Okay, so not only forming, but they are also getting disrupted. Okay, so it is very well explained by seafloor spreading principle. Okay, which was provided by Harry S. Okay, so here we'll be seeing that the life of the oceanic crust, it is almost around 200 million years. Okay, so this is an average life of an oceanic crust. Okay, then destructibility, it is low. Okay, and it is high. Okay, very good. So there is no destruction in the continental crust. It only deforms, it never subducts and has no destruction. Okay, good. Since the thickness of the oceanic crust is low, the intrusion of magma becomes easier. Okay, hence the oceanic crust subducts into the mantle and destroys itself. Okay, so here we can see we can also add the factor of buoyancy. Okay, we can also add the factor of the convection current, and it is getting formed near the mid-oceanic ridges, and it is getting destructed at the trenches. So this we can explain here, and we can say this is a cycle which is continuously going on. That is the construction and the destruction of the oceanic crust, which is taking place in the crustal part here. Okay. Now, the seafloor spreading theory and the plate tectonic theory have proven that in the mid-oceanic ridges, new ridges are formed. Hence, new ocean floors are formed, and thus this makes the oceanic crust and continental crust completely different. Okay. So here we can see that you have given a perspective in the conclusion. So this is a good conclusion. But if you look at the question again here, that the only similarity between oceanic crust and continental crust is both are crust elaborate. Okay. So here we'll be looking at the oceanic crust and continental crust. Okay. They are different in composition. Okay. Then density, depth, volume, etc. Okay. Thus, they helps us to understand the plate interaction and various geophysical phenomena like volcanism, earthquake, etc., and their predictions. Okay, so we can have this part which helps in us in the disaster management. Okay, disaster management of the region, or we can say the economic perspective of the region. So here we can see that we can end our answer uh, in this format also, where we are looking at the physical geography plus the human geographical aspect here. Okay, so in this way, okay, there are certain mistakes which we need to identify, that this is the continental crust and this is the oceanic crust. Okay, we can also add a diagram in this part, like here we can provide here that this is the mid-oceanic ridge. Okay, this is continental crust. This is oceanic. This is also oceanic. Here we can provide the various the motions of the convection currents. Here we can say that this is more basaltic, or we can say this is more of mafic, and this is more of felsic in this part here. Though we will see that the continental crust, it has been ancient in their origin. Okay, they have formed around 3.8 billion years ago. Okay, so in this way, we are able to provide that how there is formation of this part, that is mid-oceanic ridges, and how this part of the oceanic crust, it is getting disrupted. Okay, so this is the part which we can add up here, and we can obviously move over certain uh, parts. Yeah, it was mistakenly wrote. Okay. So did you get this, Priti, that how we can have a value addition of this answer? Okay. So here we have what we have seen, that we have also added up here certain name of theorist. Then yes, we have added the models in the conclusion part, but we can conclude it in a different way, in a better way. Okay, and because also introduce in a better way here. Okay, you can bring in more perspective and the human aspects also. Okay, so let's now move to the next question. Second question.